Hi everyone, so this is the second video for chapter 9. This will be going over the multiple choice questions. Again, it's just broken into two separate videos for upload purposes because otherwise they get too long. This slide has the key parts of the free response questions that I had mentioned at the end of that video. I say these are the things that I would really focus on in terms of like trying to memorize something. So the first question says, if a producer is hiring 20 units of labor and 6 units of capital, which is bundle A, the price of labor is $10. The price of capital is $2, and at A, the marginal products of labor and capital are both equal to 20. Beginning at A, if the producer increases labor by 1 unit and decreases labor by 1 unit, then what will happen? So, at A, we know that we are using 20 units of labor at a wage rate of 10, and our marginal product of labor is 20. We're using 6 units of capital at a rental rate of 2, and our marginal product of capital is 20. So our total cost is going to be 20 times 10 plus 6 times 2, which is 200 plus 12, which is 212. If we were to have an imaginary point B, and at point B, the producer increases labor by 1 unit, so that means our labor is going to be 21 units. Our wage rate is still 10. Our capital is 5, and our rental rate is 2. Then total cost would be 21 times 10 plus 5 times 2, which is 210 plus 10, which is 220. So our costs increased by 8. And looking at our answer choices, we know that our cost does not remain constant. We are making the assumption that we are on the same isoquant for A and our B that we just kind of named B. So our output will remain constant because we're on the same isoquant. And we know that our costs are going to increase by 8. And then both cost and that doesn't work either. So the only one that makes sense is C. Next question says, a producer is hiring 20 units of labor and 6 units of capital, bundle A. This is the exact same problem, but it says it wants to know what we should be doing. The producer is, how are they performing? So we are going to use the little table that I made at the end of the free response video. And we are going to know that the marginal product of labor over the wage rate and the marginal product of capital over the rental rate. And we know that our labor equals 20, the wage is 10, and our MPL is 20. Our K is 6, our R is 2, and our MPK is 20. So we're going to substitute that in over here. And when we do that, we are going to get 20 over 10 and 20 over 2, which simplifies into 2 and 10, and it's less than. And since it's less than, that means we're using too much labor. Meaning we should use less labor and more capital. Which is option C. Should use more capital and less labor. The expansion path shows us the connection of optimal points where different isoquants are tangent to different isocost lines. So I'm going to use our graph on question 8, and I'm just going to pull it over here real quick. And we're going to acknowledge that this will probably not be a very beautiful picture, but that's all right. And what we're doing with this is I just want you to be able to see what it is. The expansion path is the connection of all of these little optimal points where the isoquants and the isocost lines are tangent to each other. So again, this will not be any sort of straight figure, but if it were something like that, that's what it would show you. And it's the cost minimizing input choices as the firm's output levels change. Wherever the lines are tangent is cost minimizing. For that particular level of output. So if we connect all of those tangent lines, it's showing us the path of the firm wanting to continuously expand output. That's the path that it should follow. The price of capital is $50 per unit. What is the price of labor? So to find that, we are going to choose any of our isocost lines. I'm going to choose the lowest one, just so that my numbers are a little bit smaller. And I know that K is going to be equal to 100. L is going to be equal to 250. R is 50. And W is unknown. So 100 times 50 equals 250 times W. 100 times 50 is 5,000. 250 times W is 250 W. Divide by 250. And we get $20 equals W. Oops, sorry. It doesn't matter, but how many units of labor should the firm use in order to produce 400 units of output at the lowest cost? So for 400 units of output, we're going to find where Q equals 400. So that's this isocost line. In order to do that, we need to find out where this point actually is. We know that they're going to be using 60 units of capital. So we need to figure out their equation. So to find our equation, we're going to have K equals 100 minus something L. And to find our something, we're going to use our marginal rate of technical substitution formula, or our slope formula, whatever you really want. It doesn't really matter. If you're using your marginal rate of technical substitution, then there's an extra negative sign. If you're not, then there's not. And it's going to be negative 100 minus 0 over 0 minus 250. Just going to be negative 100 over negative 250 equals 0.4, which means our slope was a negative 0.4. So 0.4 goes here because we already have our negative sign. Then we can substitute in our 60, that's right here. So we're going to have 60 equals 100 minus 0.4 L. Subtract 100 from each side, and we get negative 40 equals negative 0.4 L. Divide by negative 0.4. And we get 100 equals L. The minimum cost of producing 800 units of output. So same thing, we're going to find our Q is equal to 800 and look at that isoquant line. Is, in order to do that, we have to find the equation of that line, because where there's tangent is minimizing costs. So we know that our rental rate of capital is $50. And every single point on this yellow line has to cost the same. So I am going to do 150 as our K times 50 as our rental rate of capital equals 7,500. So our answer is B. (11) says which of the following combinations of capital and labor lies on the expansion path. So to do that, we're just going to kind of substitute things in and see which one works. So for the sake of time, I'm going to start at the bottom, but you could really do it whatever way you wanted. And we know that all of these lines are parallel to each other, which means they all have a slope of 0.4. So I'm going to do 200 So K equals, if we start here, 200 minus 0.4 L. If we're trying to find the point on the expansion path for this line, and we substitute one of our points in, and we do 130 equals 200 minus 0.4 L. We subtract 200 from each side. We're going to get negative 70 equals negative 0.4 L. Divide by negative 0.4. And we see that we get 175 equals L. So 130 equals K. And 175 equals L. Essentially what you're trying to do is figure out this point, because we already know that these 2 points are on the expansion path, and you're just plugging and chugging until you get an answer. And for this one, 110 is going to be over here, and then 120 would be like way up here. So that's not even close to being on that line. 60K and 120L would be like right here, which isn't on the line. So really, you're only left with one of these two anyway. So even without having to do that much math to mark out the other two, just kind of choosing one and seeing which one works. The marginal rate of technical substitution is the rate at which the firm can substitute labor for capital while holding output constant. It's not the slope of the isocost curve, it's the slope of the isoquant. So MRTS is slope of isoquant. And then A is flipped. Refer to the following graph. The price of labor is $3 a unit. What is the minimum cost of producing 100 units of output? So you find 100 on your isoquant. Just here. We look for the line where it's tangent, so it's not crossing, it's just barely hitting. And it uses 35 units of labor. So 35 times 3 is $105, which is B. Refer to the following graph. The price of capital R is $20. Why wouldn't the firm choose to produce 5,000 units of output with combination A? So at A, we know that we should, if we were being smart and producing where we should be producing down here, right here. Where that's our Q equals 5,000, that's where we should be producing, because this point C is tangent. So that's where we're minimizing cost. So we know that at point A, we have 120 times, nope, times R is going to be 80 times L. I'm showing you where they're getting this 3/2. And we have 120 times 20 equals 80 times W. So that's going to be 2400 equals 80W. So 30 equals W. So we have MPO over MPK and W over R. And we know our W over R is going to be 30 over 2. So then we have to kind of decide what's happening. And what's happening is that our marginal product of labors over our marginal product of capital, or our MRTS, is greater than our wage ratio. And with that, we know that this is going to be true. And the reason we know that that's true is because based off of the graph, we know that we're using too much capital and need to use more labor. We need to use less K and more L, which means none of the above. And we just kind of broke all of them down slowly. You can't really say too much about our marginal products of labor and capital on their own. We just know that compared to the ratio, it's not where we need it to be. 15 says refer to the following graph. The price of capital R is 20. Why wouldn't the firm choose to produce 5,000 units with point B, just down here? So again, this time we know we should be producing at point C, because at the tangent point, you're minimizing costs. And we already know that from this question down here, we've already solved for W. I'm just going to copy that and bring it over here instead of redoing all of that work. So at B, we know that the marginal rate of technical substitution is less than 3/2. And we know that this is also true. And why do we know that's true? Because we know from the graph that we need to be using less labor, because we need to be moving this way, and more capital. Which means that our marginal product of labor over our marginal product of capital has to be less than our wage ratio, which is 3/2. And with that, just rewriting it, turns in that our marginal product of labor over our wage rate has to be less than our marginal product of capital over the rental rate. Reminder, if you don't remember what we wrote on the very first slide, if your MRTS is greater than your wage ratio, you're using too much K, need to use more L. If it's less, then it's flipped. You're using too much L and need to use more K. Refer to the following graph. The price of capital R is $20. What is the lowest possible cost at which 14,000 units of capital can be produced? 14,000 units of output can be produced. So we're going to find Q equals 14,000. We're going to look at the isocost line that hits that. The isocost line that hits that uses 180 units of capital, so 180 times 20 is 3,600, which is C. What combination of K and L should the firm use to produce 14,000 units of capital of units of output at the lowest price? So we know that this is the point that we actually want. And in order to do anything with that, first we have to find the equation of this line. So we are going to have 180 minus 3/2 L. And then from this point, if we go straight down and you draw an actual straight line, it will be 60 units of labor. So if we know that our equation of our line is K equals 180 minus 3/2 L. And again, you get your 3/2 with 180 minus 0 over 0 minus 120, 3/2. Negative 3/2, try it's a negative in the equation. Then, if we plug this 60 in for L, we can solve for K. So 60 is 180 minus 3/2 times 60. Which is going to give us K equals 180 minus 90. So K equals 90. So 90 units of capital and 60 units of labor. In the following graph, the price of capital is $100 per unit. If a firm decides that total cost must not exceed $3,500, what is the maximum of output that it can produce? So we are going to label these isocosts with their points, and we're going to calculate the total cost for them. So for A, it's using 20 units of capital, so 20 times $100 a unit is $2,000. B is 35 times 100 is 3,500. And C is 50 times 100, which is 5,000. So the one that's actually what we're allowed to spend is B. So this line, and we look at the isoquant line that hits that, and the isoquant line that hits that is Q equals 1,000, or 1,000 units of output, which is C. Which of the following statements is true? A says in the short run all inputs are fixed. This is not true. In the short run, at least one is fixed. In the long run, the firm is making the optimal input choice when the marginal rate of technical substitution is equal to the input price ratio. That's true. Diminishing returns to labor means that adding one more worker will decrease output. It doesn't necessarily decrease total output. It could, but it just means that it's decreasing new output. So the only answer choice that's left is B. $20 says if the marginal rate of technical substitution of labor for capital is 6, the price of labor is 18, and the price of capital is 9, then the firm. So we're going to have our marginal rate of technical substitution. We're going to compare it to our wage ratio. Our marginal rate of technical substitution is 6. Our wage for labor is 18. Price of capital, 6. Price of capital is 9. I clearly need more sleep. 18 divided by 9 is 2. Since 6 is greater than 2, it's greater than our wage ratio. So we should use less K. And more labor. Which is B. 21 says a cow will produce 8,500 pounds of milk if fed either 5,000 pounds of hay and 6,200 pounds of grain, or 5,600 pounds of hay and 5,400 pounds of grain. So for this, we're going to use hay as our K and grain as our L. And we know that our marginal rate of technical substitution is change in K versus change in L. So our change in K is from here to here, which is 600. And from here to here, which is 800. Technically, that's a negative, and that's a negative, but we're going to take the opposite sign of it anyway, because our marginal rate of technical substitution has to be positive. So we're going to have 600 over 800, which is 3/4 or 0.75. You overhear a businessman say, "We want to be big because there are economies associated with bigness." What he means is that long run average cost decrease as more is produced. And this is economies of scale. Economies of scope. Economies of scope in the production of goods G and W exist. This is just solving an equation, and these state the same relationship. All they did was move this to the other side, move this over here. So our answer is both B and C. And then our last one says learning economies differ from economies of scale because the former involves cumulative production and the latter involves rate of production per period, and that's just the definition. So with that, I know that several of you have or will ask for some sort of like just accumulation of all of the formulas that are used. So there will be a formula type sheet at the end of the PDF, just where I write out the handful of equations that I used and the relationships. So if you need to look back at them, if you're studying, you can do that. As always, if you have any questions, let me know. I hope you have a great week.